Right. Well, seems as though I still got the teacher bug in me, so I may as well roll with that. It's an important lesson for you guys. I'm teaching all the things that I think are clinically not well understood that would help uh, people provide more effective care. O2 content. School might, and I'm sorry, not school, but work. They might give these little, these little one-off type of know, in services for, with the document CEUs and things like that. But this isn't that to me. This is more important. This is what I do and what I think about how I implement what I learned cognitively, what I learned in the classroom, how it helps me clinically, and why it makes test taking much easier if you just spend the time to understand it while you have the chance or when you take the time to do it. But when you're talking about O2 content, O2 is going to be it's going to be in two places. You know this. What are these two places? Bound to hemoglobin. That's where like 98.5% is the number I've been using. So I guess I'll roll with that. And where else do you have O2? Dissolved plasma. Now, if you looked at my previous lesson on the oxyhemoglobin dissociation curve, that's talking about the relationship between oxygen connecting to hemoglobin at the lungs and at the tissue and what affects that. Okay. This is something different. This asks the question how much volume the O2 molecule is in my body. We'll say volume because it's the answer is going to be in milligrams per deciliter, which is volume percent, and then I'll explain that part. Or yeah, mLs per deciliter. And I'll explain that. How much O2 in terms of volume? How much of this molecule is in my body? Because however much is in there for me to function day to day is obviously how much I need to feel normal if I'm feeling normal. But if I'm not feeling normal, there could be a much more internal problem involving not necessarily a problem with the lungs or the heart, but a problem with having enough of the red blood cell to carry the oxygen. But we don't use red blood cells. We use hemoglobin as an indicator of adequate really adequate red blood cells and O2 carrying capacity. Because when you look at hemoglobin, Let's look at hemoglobin. Hemoglobin carries nearly all of the O2 in our body. Okay, so we need to understand, you must understand normal hemoglobin values if we intend on understanding the significance so we must know normal hemoglobin values if we intend on understanding the significance hemoglobin plays in O2 delivery in terms of getting it to the tissue, but also carrying capacity. How much? How much O2 is in our body? First question that's asked with oxygen content. How much O2 is in our body? As opposed to O2 hemoglobin curve, which is a model that illustrates affinity. I don't even know if that's spelled right. You guys know what I mean. This question, the O2 hemoglobin curve, is a model that illustrates affinity between, do it like this, O2, red, and hemoglobin. But we're asking now how much. There are 1.34 mLs of O2 for every Very important. 1.34 mLs of O2 for every gram of hemoglobin. That can be expressed as 1.34 mLs per gram of hemoglobin. Okay. It's a normal hemoglobin. Well, can I write? Sorry, guys. Okay, sorry about that. A normal. So what I want to do is going to combine values between male and female here. Hemoglobin for an adult, but typically it's important to remember that men carry more hemoglobin than women, only by a little bit. A normal hemoglobin for an adult is, we're going to say 14 to 17 grams per deciliter. Shouldn't say delta, that should say grams per deciliter. Right? Now, we're not going to look over this because it's uncomfortable. But that's the reason we're going to look at it. Grams per deciliter. All right. Units of hemoglobin are grams per deciliter. And like doing grams per deciliter. It's of O2 and hemoglobin. MLs. Okay. Per gram hemoglobin. This is important if you want to find the right answer and if you want to actually understand this. Okay. This is going to be oftentimes presented in gram percentage. They can say gram percentage because it's a gram over a deciliter and it expresses a percentage. Ml per gram, it's a little bit different, but that would also technically be able to be pronounced as volume percentage because you're looking at a volume over one. Okay. Your final answer, though, this is my whole point. Final answer should be in, oops, grams. Nope. See how wrong I was? As long as I've been doing this, I was still wrong. So you gotta be careful. MLs per deciliter or expressed. Okay, so here can be as the final answer should be people question and we should take time to explain and just to recap is to calculate the O2 content, be mindful that